Today's lesson is the last lesson over functions. Did everybody hear me? Today's lesson is the last lesson over functions. Tomorrow we will review everything that we've learned, and Wednesday you will have a CBA. Today there's really not anything new besides what the difference between a continuous function and a discrete function. Everything else we're doing today you've already done. Okay? So here's the deal. A continuous function is a set of data that is said to be continuous if the values belonging to the set can take on any value within that interval. Meaning, when you graph it, if you connect the dots, it's continuous. Okay, so look at the bottom down here. Do you see how it connects the dots? Yes, okay. Discrete is a set of data if the values belonging to the set are distinct and separate. They are unconnected values. So if you look down here, these dots are not connected. That is discrete. Does that make sense? It's very easy. Yes, if the dots are connected, continuous. If the dots are not connected, discrete. Discrete are the easiest to list the domain and range because you don't need an inequality. You just list the numbers. Over here, you would have to have an inequality to list the domain and range. Okay? Now, let's go through some examples. Continuous. The height of a horse. Why would it be continuous? Can they be a decimal? Yes. So I would have to continue to connect that as the horse grows. Yes? Discrete. The number of people in my class. Would I connect that, or would I have exactly 1, exactly 2? Do you see what I'm saying? I wouldn't connect those. I can't have 1.3 people. Okay? Over here, continuous. The time to complete a task. Can time be measured in fractions and seconds? Yes, okay. Discrete. The number of TV sets in your home. Can you have half of a TV? No. No, you can't. Okay. Continuous. The outdoor temperature. Can the temperature go up in intervals by fractions and decimals? Yes. Discrete. The number of puppies in a litter. I can't have a fraction of a puppy. Like I either have 1 or 2 or 3. Make sense? All right. Continuous. The speed of a car. Is it going to keep speeding up and have decimals? It can't just jump from 1 mile per hour to 20. It's got to go 1, 1.2, just fast or slow. Okay? Discrete. The number of questions on a math test. Yes. Okay? Are y'all good with the difference? So you have this to refer to if you need help. Okay? Flip to the back. So for continuous in a domain, it's going to have all numbers in an interval. So it might stop. It might be from a dot to a dot, but it's all connected within that interval. Yes? But over here for discrete, your domain is a set of input values consisting of only certain numbers. Okay? Do y'all understand the difference? Okay, here we go. Example 1, we're just going to go graph this, and we're going to classify this as continuous or discrete. So they gave us this function, and they gave us this domain. So how would I graph this? The first thing I'd have to figure out from the domain, what would I need? To graph this, what do I need? I have the x's. What do I need? I need the y's. I need the range. So make a table. Did they give you specific domains? So I have to only use 0, 1, 2, and 3. So what do y'all think? Is it going to be continuous or discrete? Discrete. Because they gave me specific domains. So this will be discrete, but we're going to look at it on a graph. So how would I fill in this table for the range? What's the easiest way? My y equals button. Okay, so I'm going to type in 2x minus 1. Where do I go from here? Second graph, and I'm filling in when x is 0, y is -1. When x is 1, y is 1. When x is 2, y is 3. And when x is 3, y is 5. And I would just go graph this. And it is discrete because I would not connect these dots because they gave a specific domain. So it's discrete because they gave a specific domain. Now, if they had just given you this function and they didn't specify the domain, it would have been continuous because I could keep graphing on and on and on. Okay, but because they gave a specific domain, it is discrete. All right, turn the page. Find the domain and range of coordinates. Decide if it's a function. So here we go. Domain is the, range is the. All right, so you would list the x's. So 2, -5, -5, and 0. So is that a function? Why not? The x is repeated, so over here I'm going to put no. The range would be at -3, 8, 6, and 7. Okay, let's look at the next one. The domain is the x's, so my domain is 0, -1, -5, and 0. Is this a function? Why not? The zero's repeated, so no, it's not a function. The range would be -5, 4.5, 6.8, and 7. All right, now we're going to look at graphs, and we're going to look at are they continuous or discrete, and we're going to list the domain and range. All right, so let's look at this first graph. Now, do y'all see these little arrows? That's not part of the graph. They're just pointing to the dots, okay? So the graph is this dot, this dot, this dot, this dot, and this dot. So is that continuous where the dots are connected, or is it discrete where they're just individual dots? So this is discrete. Therefore, since it's discrete, I would list the domain separately. So here's a dot. What is the x value of this dot? If y'all need to, go label it. This is 0, 1, 2, 3, 4. I don't need to go further. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again, what is the domain of this dot? 0. What is the range of this dot? 8. Okay, go to the next one. What is the domain of this dot? 1. What is the range? 6. This one, the domain is 2. The range is 4. This one, the domain is 3. The range is 2. Now look at this next dot because this one confuses people. What is the domain? What is the x value? 4. What is the y value? 0. Very good. Is this a function? Why? The x did not repeat. What if I didn't have those? How would I tell if it's a function? Perform a vertical line test. So it would only touch one dot, so I'm good. All right, let's look at this next one. Is this continuous or discrete? Continuous, because it is not just individual dots. It's connected. Okay, let's go label. This would be 0, 1, 2, 3, 4. And label your range just so you can see. Now, the first thing I'm going to ask is it a function? Yes or no? Why? If I did a vertical line test, it would only touch one time. Okay. Now we're going to identify the domain. Okay, so look at the domain. From the x-axis, is there, first of all, is it like this or like this? This one. So remember, it's going to be one of these, like this, yes? Okay. So what's the furthest left on the x-axis? 0. What's the furthest right on the x-axis? 4. Then I put x in the middle, okay, and I go like this. Can it be 0? Yes. Can it be 4? Yes. Okay, now I'm only going to look at the range. So only looking at the y-axis. So it's going to be like this. What is the lowest it goes on the y-axis? 0. What is the highest it goes on the y-axis? Can it be 0? Yes. Can it be 8? Yes. Okay, on this one, the first thing we're going to look at is it continuous or discrete? Continuous. So circle that right here. Is it a function? Yes, it is, because if I drew a vertical line, it would only touch one time. Now, for domain and range, I want you to think about it. For the domain, looking from left to right, is there an arrow that's going to keep going to the left? Is there an arrow that's going to keep going to the right? So what would the domain be? All real numbers, or the little sideways infinity. Okay, look at the range. Is it going to keep going down forever? Is it going to keep going up forever? So the range is also all real numbers or infinite solutions. You don't have to write both. Okay, look at the next one. Is it continuous or discrete? Discrete. Why? They're not connected. They're individual dots. Is it a function? How do you know? Vertical line is only going to touch one dot. So the domain for this dot, what is the x value? 1. What is the y value? That's the range. Okay, I'm going to go to this dot. For the domain, the x value, where am I at? 3. For the range, where am I at? 5. Okay, for this dot, on the x-axis, I'm at 4. On the y-axis, I'm at 2. And for this dot, on the x-axis, I'm at 6. On the y-axis, I'm at -2. Did we answer, is it a function? Yes, because if I draw a vertical line, it's only going to touch each dot once. All right, y'all try this one on your own. Okay, was it discrete or continuous? Was it connected? Yes, so continuous. Was it a function? Yes, why? If I did a vertical line, it's only going to touch one time. All right. Did everybody at least get to the domain? Okay, domain. I did it in orange. X-axis. Do y'all need time to think about it? I'll give you 30 seconds. Okay, for the domain, we're looking from left to right. What is the lowest point? -5. What is the highest point on the x-axis? 6. Can it be -5? Yes. Can it be 6? So I do not put an or equal to sign. Okay, for the range, you're not looking from dot to dot. You're looking at the lowest point on the y-axis to the highest point on the y-axis. So don't look at the dots. Okay? So I'm going to give you all about 30 seconds to see if you can figure it out. Okay, looking up and down, what was the lowest part it touched on the y-axis? Does everybody agree this is the lowest right here? Where am I at? Negative 1, 2, 3, 4, 5. Yeah, -6. That thing looks funny. Okay. What is the highest point on the y-axis? 2. Can it be -6? Yes. Can it be 2? Yes. All right, try the last one on your own. Okay, discrete or continuous? Continuous. They're connected dots. All right. Is it a function? Why? Vertical line test would only touch? All right. Domain. I'm looking from left to right. What is the most left spot on the x-axis? 1, 2, 3, 4. -5. What is the most right spot on the y-axis? +5, right? Did y'all count it? I know it's hard to see. Can it be those? Yes. All right, now we're going to look at the range, the y-axis. I'm looking from the lowest dot to the highest, and it doesn't have to be a dot. It just has to be part of the graph. What is the lowest this graph goes? To these two spots, yes? Which is where on the y-axis? 0. What is the highest point on the y-axis? 5. You kind of have to count because it's so hard to read them. Can it be 0? Yes. Now this kind of looks like an open dot. It's hard to read, but I know this is a closed one. So it can be 0 and it can be 5. Okay, flip it over. We're only going to do a few more. We're not going to do the whole back. All right, on this one, discrete or continuous? Continuous. Is it a function? Yes. Domain. I'm only looking on the x-axis. Now look, right here, they're telling you the coordinate of this dot. So what would the x value be right here? 4. All right. So from the x-axis, it goes from -2 to 4. Everybody agree? Can it be -2? Y'all look at it. No, it's an open dot. Can it be 4? Yes. Okay, for the range, I am only looking at the y-axis, the lowest to the highest. So move your pencil up and down. What's the lowest this graph goes? Right here, y'all agree? Where am I at on the y-axis? 0. Where is the highest on the y-axis? 2. Can it be 0? No, that is an open dot. Can it be 2? Yes. Okay, this one. Is it discrete or continuous? Is it a function? Yes. Domain. I'm only looking at the x-axis. Now, move your finger from left to right. Is this the lowest it goes on the going left, or does it keep going? Is it going to keep going forever going left? Yes. Is it going to keep going forever going right? So all real numbers. Now look at the y-axis. Going down, is it going to keep going forever? Going up, does it keep going forever? No, there's a stopping point. Okay? Right here. So it's not between two numbers, it's lower than 3. So I write y is less than or equal to 3. Because it's not between 2, it's just lower than that 3. Are y'all good? All right, we're only going to do this one and then we're going to be done. It says, do y'all need to do this one? Y'all know how to make a graph, right? Okay, so just looking at it, would it be continuous or discrete? Discrete, because they are individual points. The domain would be that. The range would be that. Would it be a function? Yes, y'all got this. Okay, I'll pass out your assignment. On your assignment, you're going to answer 4 questions. The first thing I would do is circle if it's discrete or continuous. Y'all with me? Y'all want me to do number 1 with y'all? So number 1, what would I circle? Why? Because it's not individual dots. That's why. Is it a function? Yes. I'm going to highlight the x-axis for the domain, and I'm going to look from left to right. Is there a stopping point going left, or is it going to keep going left forever? Okay. Is there a stopping point to the right, or is it going to keep going forever? So my domain is all real numbers. My range, I'm going to highlight a different color so that I only look at the y-axis. Going down, is there a stopping point, like the lowest it's going to go? Yes. Going up, is there a stopping point, or is everything just above that lowest point? So I'm going to write y is above, y is greater than or equal to, and what was this number at on the y-axis? -3. Now for number 2, it's just going to be individual numbers. If you need to go number, this is the x-axis right here. This is 1, 2, 3, 4, 5, 6. Make sense? This is the y-axis right here. So that's 1, 2, 3, 4, 5, 6 that it goes to. Okay, get busy. The whole paper is basically doing this.